Now we're going to simplify a complex fraction. I'm going to use an example of number 46 from page 566 in our book. This is the problem. I need to look at this as three distinct problems. I've got the numerator, that's two fractions that need to be added together. I also have the denominator, that's two fractions that need to be added together. Once I've simplified both the numerator and the denominator, then I want to put the two together as a division statement and simplify further. So I'm going to start with the numerator. And in order to get the least common denominator, I want to factor the numerator. So all I can do is factor out my greatest common monomial factor, which is 2. And on this fraction, I can factor that as a difference of cubes. So I use my difference of cubes pattern. In the denominator, in the red, I can factor out a 3 from this denominator, and I can't do anything with this one. Now, in order to get these two fractions to add together, I have to have a common denominator. So I'm going to have to multiply by 2 over 2 here because this denominator was missing this 2. On this fraction, I need to multiply it by x minus 3 over itself, which is just 1, so I'm not changing any value. All I'm doing is changing the way that this looks. Down here, in this denominator, I need to multiply it by 3 because this x minus 3 is missing this 3. So now I'm going to simplify the numerator. Now I'm not going to skip any steps here at all. I'm going to write everything in. So I didn't distribute this 3 yet on purpose because I want you to see every single step. And that's over 2 times x minus 3 times x squared plus 3x plus 9. The denominator is going to be 5x, 5x minus 9 over 3 times x minus 3. So I'm going to simplify my numerator. I'm going to distribute the 3. So 3x minus 9 plus 2x, and that's over my common denominator, 2 times x minus 3 times x squared plus 3x plus 9, and that is over my 5x minus 9. I'm not going to distribute this 3 in the denominator, and the reason is because I'm hoping that in the end, when I put them together as a division statement, that I'll be able to do some reducing there. So 3x plus 2x gives me 5x minus 9. Now look what I'm noticing. When I do this numerator, 5x minus 9, I have a 5x minus 9 there. That's going to be able to simplify later. Divided by 2 times x minus 3 times my trinomial, and that is all over 3x minus 9 over 3 times x minus 3, and I don't want to multiply that out yet. Okay, now what I'm going to do is I'm going to write this as a division statement. The fraction bar is a division sign. And like I said, I'm not going to be skipping any steps here because I want you to see exactly where everything is coming from. So divided by 3x minus 9 times 3 minus x minus 3. Oops, that was a 5. 5x minus 9. So now I'm going to write it as a multiplication statement because division is the same as multiplying by the reciprocal. Now, this 5x minus 9, if I can reduce that, I have to reduce it all at the same time. I can't just go chopping out the 5x. Same thing down here. It has to all go out. I can't just take out the x one thing at a time, but because I have a 5x minus 9 in the numerator, 5x minus 9 in the denominator, that gives me 1. I can also reduce the x minus 3's, and what I'm left with is 3 over 2 times the quantity x squared plus 3x plus 9. So now go try the problem yourself. Again, it's on page 566. It's number 46.